I'm going to work an example about percentiles, quartiles, and box plots. So anytime we have a set of data, we can list the data out and divide it into sections or quarters. We have certain points along this data set that are special. We have a minimum value. We also have quartile 1, which would be the location that divides the data set, putting 25% of the data below it and then 75% above it. Quartile 2 is in the middle. That puts half or 50% below and 50% above. Quartile 3 is a location that puts 75% below, 25% above. And then we have the maximum value. So these 5 pieces of data are called the 5-number summary. We use those 5 pieces of data to construct box plots. Now, in addition to these special quartiles, we also have other percentiles. Maybe a piece of data that divides the data set putting 10% below or 15% below. So we're going to work a problem involving percentiles. This problem is about speed limits. So we recorded the speed of these drivers, and this is the list of all the speeds that the drivers were going. So I've already preloaded this data into StatCrunch. It can be found by going to Data, Load from your group, and here is our group, and it is called Speeders. Here we go. So we're going to try to find these different percentiles. So we're looking for percentile 10 or P10, P90, which is percentile 90, and all these other values. And then we're going to look at a box plot. So this is how we do it in StatCrunch. We go to Graph, and we're going to go down to box plot. We need to tell it to look in var1, which is where all the data is. And we're going to I want to find out what the mean is. I'm going to click on mean, and I want my box drawn horizontally. That's a personal preference, and I'm going to hit compute. So here's my box plot, and this gives me the mean, this green line. So if I hover over that, it's showing me that the average speed from this list is 66.25 miles per hour. So this is how we can draw a box plot. Now what we want to do is go back and look at the different percentiles that we're looking at. Let's go back. I'm going to X out of this, and we're simply going to Stats, Summary Stats, Columns, like we've done before, but down here is a place where we can list out all the percentiles that we're interested in. So we are asked to find the 10th percentile here. So I'm typing 10, and then we want the 90th percentile, then we want the 85th percentile, and the 25th, and the 50, and the 75th percentile. Separating all these by commas and hitting compute. I forgot to go back up here and select var1, so let's hit compute. So here we go. Here's all the percentiles that we needed, plus we've got our minimum speed, the maximum speed of 78, and all these other percentiles that we were asked for. I went ahead and filled out the 10th percentile, which is 58, and that just came from StatCrunch. And here's the 90th and the 85th. So I filled out all the data. I wanted to point out to you that P25, the 20th percentile, is also Q1. It's the first quartile value, and that is 62.5. So it would be about right here, and that looks about right. That's going to put about 25% of the data below, and it puts 75% of the data above this location. P50 is the 50th percentile, which is also the median because it's the middle, and we also call that Q2. That would be 66 miles per hour, which would be located here in the middle. And that puts 50% below and 50% above. P75 is what we call Q3. We found that as well in StatCrunch. It's here. If you slide over, there's the 75th percentile. But also, if you look here at Q3, it's the same thing. So that would be about right here, and that puts 75% of the data falls below that location and 25% above. So that's how we can find all these different percentiles in StatCrunch. But let's look at the problem here. The problem says that we are trying to establish what the speed limit should be on this road. So they went out and clocked all these drivers and got these speeds to try to figure out what was going on. There is something called the 85th percentile rule, and that is where they set the speed limit based on the fact that 85% of drivers should be going at or below that level. So what would this 85th percentile be based on our sample? Based on our sample, the 85th percentile would be 73.5 miles per hour. So we need to decide is what should the speed limit be on this road. It is set at 65. However, 85% of drivers are going 73.5 miles per hour or below. So if we needed to set the speed limit for this road, we would need to look at that, which the 85th percentile would be 73.5. But since we normally put speed limits at multiples of 5, we would probably set that speed limit at 75 miles per hour. The next part asks, does the existing speed limit on Highway 405 conform to the 85th percentile rule? And no, it does not. Box plot we already did in StatCrunch.